video, I'm going to talk about tips of memorizing three geometric functions: sine, cosine, and tangent. First way of memorizing, I guess remembering for me, is to memorize SOHCAHTOA. I'll write it in pink color. SOHCAHTOA. There are two ways of memorizing, and SOHCAHTOA is one of the ways of memorizing sine data, cosine data, and tangent data. And SOHCAHTOA can be unfamiliar at first, but if you know the definition of SOHCAHTOA, you'll figure out that SOHCAHTOA is easy stuff to deal with. So at first, we know that sine data right over here is equal to opposite side over hypotenuse. And the first letter, which is so, literally just means for S, that means sine right over here, is equal to O, which is opposite side, over H, which is hypotenuse. And for cosine data, we know that cosine data right over here is equivalent to adjacent side over hypotenuse. And also the second letter, ka, also shows that C just means cosine data right over here, and A means adjacent side over H, which is hypotenuse right over here. And for the last word, I guess tangent data, we know that tangent data is equal to opposite side over adjacent side. And the civil word for this is TOA. And we can figure out what is TOA if you look at the first and second words. That tangent, T means tangent, right over here. Tangent data is equal to opposite side over adjacent side. And these words, SOHCAHTOA, just is a simplified version of showing these sine data is equal to opposite over hypotenuse things. And so we can know that SOHCAHTOA is a simplified version, and we just figure out the first way of memorizing the sine data, cosine data, as well as the tangent data. And we're going to talk about the second ways. And the second ways is the way that I usually prefer using it, because it is easy to memorize. I think it is easier than SOHCAHTOA right over here. And let me fix this a little bit. Okay, so the second tip, I guess the way that I prefer using it is defining sine data, cosine data, and tangent data using its first letters, like SOHCAHTOA, but SOHCAHTOA simplified these three letters. But this way, the second way is of using these first letters. So if we were to do it, we're defining sine, cosine, and tangent. And I like this way because it's I can not only understand sine, cosine, and tangent ways easily, but also I can figure out what geometric function should I apply for the different situations or questions. So before we learn about this second tips, we need to know that we need before we apply the second tips, we need to know that we are making this A into the center angle, and we need to make A for center angles, and then we need to start. And so if you use sine data, cosine data, and tangent data right over here, cosine data, and tangent data, I said that we are using the first words. And we know that I'll start from cosine first because it is easy to memorize with the right triangle. It is adjacent over hypotenuse. So if you were to say that we are doing cosine of A, it should be this side over hypotenuse. I'll just call this length X, I will call this length Y, and I will call this length H. So if you use this second step, I said that we are using the first letter of cosine, so we're always starting from the up to the bottom. So we are writing C from the H all the way down to the bottom side, which in this case cosine of H should be X over H. So we just wrote this cosine, which is C. So it was gonna be equal to cosine of theta is equal to X over H, which is in this case adjacent over hypotenuse. And I'll write for sine theta. For sine theta, we are also using the first letter of sine, which is S. And we know that if we were using sine of this angle A, I'll just call it theta. And it was going to be equal to opposite over hypotenuse. So if we define this geometric function, we write S in this way, S, which was going to be equal to, in this case, Y over H. Y over H means Y is opposite side right over here, and H is hypotenuse. We're right now following these steps right now. And for the last thing, for tangent, we are also using tangent's first letter, which is T right over here. And we write T in this way. So for tangent theta, it will going to be equal to Y over X, which is same thing with opposite over adjacent, right over here. So we just use the second ways of memorizing sine, cosine, and tangent. And it is not far away different with the first way of SOHCAHTOA, but I like this way because if there is a right triangle, we can know what kind of trig function should we apply for that question. So we practiced these two questions, these two these two tips, and let's solve some basic examples of finding the size using the geometric function. And I said that I prefer using this first, using the second way, so I'm gonna use it. I'm gonna apply this into these questions. For the example 1, it says to find the length of BC right over here. And it says to find the length of BC right over here. And it is made with question mark. And we need to use these given angles and given lengths. But if we use cosine, like this C with the center angle A, we can know that cosine is equal to adjacent side over hypotenuse. But we know the value of hypotenuse, which is 5, but they didn't tell us to find the value of AC. So that means we cannot apply for the cosine. And what about tangent right over here? If you were to write tangent, that means opposite side over adjacent side. We want to find the opposite side, but in order to find opposite side, we need to know the adjacent side in order to solve for it. But we don't know the adjacent side either, so that means we cannot apply tangent either. And what about sine in this case? Well, we write sine in this way, as we learned in the second steps, the second ways. And we know that it is opposite side over hypotenuse. And so we write sine in this way. So that means we can apply sine right over here because it involves the given size and also the missing size. And if you know the given size and the missing size, we can figure out the missing size. And so in this case, the sine right over here, we use sine in this case. So we use sine in this case. So if you were to solve for this triangle, solving for this BC, length of BC, we can make an equation that we use sine. So the sine of theta, which is 40 degrees, is equal to, this is sine theta, which is equal to, the sine 40 degrees is equal to sine of theta, but we input theta into the degrees. So that's why I did sine of 40. And so sine of 40 is equal to opposite over hypotenuse. So opposite side, which is the missing value, so I'll just call it y over hypotenuse, which is 5. In order to isolate y, we need to multiply 5 to the both sides. And if, in this case, on the right side, 5 we're going to cancel out. So y we're going to be equal to 5 times sine of 40. And we're done. So let's go to second equation. Second problem. It says that find the length of BC right over here. Find the length of BC right over here. So let's apply sine, cosine, and tangent ways that I explained in the second ways, which is second ways. So if you were to do that, let's say A is a center angle, and let's draw cosine. Well, we know the value of AC, but they didn't tell us to find for the length of AB. So that means we cannot apply for the cosine. And what about the tangent? Well, we drew tangent in this way, which is opposite side over adjacent side in this case. But the center angle is 50 degrees, which is B in this case, not A. So opposite side over adjacent side. Opposite side over adjacent side. So that means we are applying tangent for this question. We got it by drawing tangent. So if you make an equation to solve for this missing side, it will going to be equal to the tangent of the data, which we will input as this center angle, which is 50 degrees, is equal to, well, if we go back to the page, this tangent of data is equal to opposite over adjacent. So opposite side, which is 5, over adjacent side, which is the missing value. So I'll just call it x. So in order to solve for x, we can multiply x to the both sides. Multiply x. And in the right side, the x value we're going to cancel out, and only 5 we're going to leave. And for the left side, we're going to be x times tangent of 50. But we're solving for x, not x times tangent of 50. So we can divide tangent of 50 into the both sides. And in the left side, only the x value we're gonna left, and tangent of 50 case we're gonna cancel out. So x is equal to 5 over tangent of 50. And in the first example, we were using the sine, and in the second example, right over here, we were using tangent, sorry. And let's solve for the last problem here. It says define the length of AC. Find the length of AC. So let's apply for the sine first. Well, the given angle should be the center angle. So that means A should be the center angle. I'll write it down. Center angle. Center angle. And for sine, we'll write S value like this. So that means sine is opposite over hypotenuse. Opposite over hypotenuse. So we know the value of hypotenuse, which is 4. But we're not finding the length of BC. They didn't ask us to find the length of BC. They asked us to find the length of AC. So that means we cannot apply for the sine in this case. So what about the tangent case? Well, we write tangent like this. And it will going to be equal to opposite side over adjacent side. So opposite side over adjacent side. Well, if we know the value of BC, we can figure out the value of AC, but they didn't give us the length of BC, so that means we cannot solve for this length BC using the tangent either. And what about the cosine in this case? Well, if it's the center angle is A, we write C from the hypotenuse all the way to the base side. So and for the cosine theta, it is equal to adjacent side over hypotenuse. So adjacent side, which is this missing value, over hypotenuse, which is 4. And they gave us the length of AC, which is the missing value, and also the AB. That means we can make equation for it and solve for the AC, which is the missing value. And in this case, it was cosine. So if you make equation for it, it is cosine of the data, which we input 59 degrees. This is the center angle, 59 degrees, is equal to the adjacent side, which I will just call this length x, over hypotenuse, which is equal to 4. We can isolate the x value in the right side by multiplying 4 to the both sides. The reason why I'm multiplying 4 to the both sides, not just right side, is because we want to keep this equal. So the 4 we're going to cancel out. In the right side, only the x value we're going to leave. And in the left side, it will going to be equal to 4 times cosine of 59 degrees. And we found we solved for the equation right over here. And that's the reason, these are the reason why I prefer using this second step of using these first letters, C, S, T. It is because we can understand the cosine, sine, tangent like this in these problems. We can also know if we can apply actually cosine, sine, or tangent. We can actually choose whether we what geometric function we're going to use for questions. So that's why I love this. That's why I love this way. And we talked about the 2 ways of memorizing sine, cosine, and tangent. We also solved for example 1, example 2, as well as example 3. And we are done.